Hello, welcome to the channel The Math Spot. Today our lecture is about de Moivre's theorem. So, in the field of complex numbers, de Moivre's theorem is one of the most important and useful theorem which connects complex numbers and trigonometry. It is also helpful for obtaining relationships between trigonometric functions of multiple angles. De Moivre's theorem is also known as de Moivre's identity and de Moivre's formula. So basically, this theorem is named after the great mathematician de Moivre, who made many contributions to the field of mathematics, mainly in the areas of theory of probability and algebra. So what is de Moivre's formula? So for any real number x, cos x plus iota sin x whole power n is equals to cos nx plus iota sin nx, or e to the power I theta whole power n is equals to e to the power I n theta, where e to the power I theta is equals to cos theta plus iota sin theta. Now we will prove this de Moivre's theorem. So first we will apply mathematical induction to prove this theorem. So first we know that cos x plus iota sin x whole power n is equals to cos nx plus iota sin nx. This is our equation number first. So we will prove it for n is equals to 1. This is our first step. So what we will write, put n is equals to 1 in equation number first. So we get cos x plus iota sin x, which is true. Now we will do it. What is our step 2? So step 2 is let formula is true for n is equals to k. So we'll do it for n equal k. So we get cos x plus iota sin x whole power k is equals to cos kx plus iota sin kx, which is equation number 6. Step 3rd. N equal k plus 1. Now we will prove this theorem for n is equals to k plus 1. Sin x plus iota sin x whole power k plus 1 is equals to cos x plus iota sin x whole power k dot into cos x plus iota sin x. From equation 2nd, we will put this value, then we will solve it. We get cos k plus 1 x plus iota sin k plus 1 into x. That is cos x plus iota sin x whole power k plus 1 is equals to cos k plus 1 x plus iota sin k plus 1 x, which is true for n is equals to k plus 1. As the result is proved, since the theorem is true for n equal 1 and n equal k plus 1, so it is true for every n is greater than is equals to 1. Now we have a corollary that for all values of n, integral or fractional, positive or negative, the value or one of the values of cos theta plus iota sin theta whole power n is equals to cos n theta minus iota sin n theta. So we have some points or to remember that sin theta plus iota cos theta whole power n does not equals to sin n theta plus iota cos n theta. We cannot write it like this, but then what will be the value of this? So we will find its value. So we can write it like this. So this is the value. Now we have another property that cos theta plus iota sine phi does not equals to cos n theta plus iota sine n phi. We cannot write it like this because de Moivre theorem is applied only when the real and imaginary parts are cosine and sine of the same angle. Here theta and phi are two different angles. So at some places you will see the notation says theta, which means cos theta plus iota sine theta. This notation means that. Okay, we can write it in de Moivre's form also. So this is the de Moivre form we have. So next property is to separate complex numbers a plus iota b whole power n into real and imaginary parts. So we will put a is equals to r cos theta and b is equals to r sin theta, and we will put both the values of a and b in this when r is equals to, where r is equals to a square plus b square and theta is equals to tan inverse b by a. We know that theta is amplitude. So what is a plus ib whole power n r cos theta plus iota r sin theta whole power n? So we can write it like r to the power n cos theta plus iota sin theta n equals to r to the power n cos n theta plus iota sin n theta. We study about this in previous properties. So what we get is a plus iota b, where a is equals to r to the power n cos n theta and b is equals to r to the power n sin n theta. So based on previous concepts, we have some results to be remembered, that cos theta plus iota sin theta whole power n is equals to cos n theta plus iota sin n theta. Second is cos theta minus iota sin theta whole power n is cos n theta minus iota sin n theta. Then this cos minus n theta plus iota sin minus n theta. We can open it also. Cos n theta minus iota sin n theta. Next is cos minus n theta minus iota sin minus n theta. So we get cos n theta plus iota sin n theta. Next is cos theta minus iota sin theta. And what the property of this? Cos theta plus iota sin theta. And our last property is we get cos alpha plus beta plus gamma plus so on plus iota sin alpha plus beta plus gamma plus and so on. So today we learn about de Moivre's theorem, and in our next lecture we will do some examples based on this complex number, all the properties and everything we studied before. So thank you for watching.